Hi, so I'm going to show you some cool relations for length and line integrals. So say that you have a line that goes like this. It's a curve. They call it line integrals. It's not the best name for it. So you have like XYZ space here and you have a line from A to B and it goes like that. So what you can do is you can parameterize this line. So you just have like R of t, and this is going to be something you should already know how to do. R of t is equal to, so this is the vector where it's x of t comma y of t. And it could be also z of t as well. It could have that. So let me add that. Comma zt. Alright, so this is your parameterization of the line. So what we're going to do is try to find the length of this curve here. So how you do that is what you do is you take the integral from t at point A to t at point B. And what is the distance? So you're trying to find the length. Length is basically just distance. And distance is equal to speed times time. So what is speed? All right, so the first thing you want to realize is that the integral, or the derivative of this position vector is velocity. So this is a velocity vector. You just take the derivative and you get the velocity. Now if you take the magnitude of a velocity vector, it takes the direction away. And velocity without direction is speed. So then this is speed here. So, alright, so I'm going to put an L here. And that L represents distance. So what did I say? Distance equals speed times time. So speed times time. We're going to just do a little bit of time. That's what the dt means, a little bit of time. So this is the equation to find the length of the curve from A to B. Now what we're going to do is we're going to take the line integral of a function. So how you do this is just say that you have some function that sort of changes at every point on the line, on the curve. What you can do is, so what we're trying to do is basically the same thing, speed times time. It's you want to do a distance. So let's just start with this. So say that you have, let me stand here so you can see f ds. So you have the integral over the curve, so this is curve C, of a function ds. So what you do is first you need to, like, say that you're not given the parameterization of the curve, you need to first parameterize the curve to get this. And then what you can do is take it from, just like this, t equals a to t equals b. What we're going to do is basically at every point on, we're just going to do the same thing as here. So like speed times time. So speed times time is equal to distance. We know that from physics. So t equals a to t equals b. We're going to do the same thing, but at every point, we're going to multiply by the value of the function. So we're just going to be basically doing f at that location, so f at r of t, multiplied by the distance, so r prime of t dt. So as we said, this is distance, and that's the ds. So this ds, this is the ds from here. And we're just multiplying the function at every point on the distance. So that's how you do that. And then what we're going to do is we're going to do, if we have a vector field, instead of just a function, we're going to do it over a vector field. So the way that that looks like is this. So you have the integral over c of f dot dr. So the vector field and then this. So as we said here, this is distance. This right here is actually displacement. So what we're going to do is take the integral from t equals a to t equals b. I'm just going to replace the f with our vector field. So the vector field at that location. And see how we're taking the dot product here. We're going to keep that the same. And like I said, this is the displacement. So we're not going to use the same distance thing anymore. We're going to actually take the absolute value away here. Or not the absolute value, the norm, the length. We're going to take the length away from here. And we're going to take the dot just with the velocity. So this is dr, which is equal to displacement. So velocity times time is displacement. So basically, at any point on the vector field, like at any point on the curve, the vector field, we're going to multiply by. We're going to multiply by the vector field at any point on the curve with the displacement. So if that makes any sense. So yeah, that's how you can remember these equations. So yeah, again, velocity times time, displacement, and that's dr. Speed times time is distance, and that's ds.